Troubleshooting SQL Server. So as DBAs, we also need to be good problem solvers and detectives. And in order to do these kinds of things, we need to have good tools and we need to understand the tools that we're using so we can hunt down whatever it is we're looking for. So in this nugget, we're going to look at those tools that help us become better problem solvers and detectives so we can track down the performance bottlenecks, the data issues, and even help out developers with how they work with our database. Taking a look at our outline and the exam objectives, we're going to start here with the SQL Server Profiler, a great tool we can use to view real-time events that are happening in SQL Server. So think of it as our little spy in the SQL Server. We can see exactly what's going on, when it's going on, and how it's going on. One of my favorite tools in SQL Server for troubleshooting. We'll also take a look at extended events in the Extended Event Profiler, which is very similar to the SQL Server Profiler. It's new, it's a lot more lightweight, and it's built right in to the database engine. From there, we'll take a brief look at dynamic management views, another real-time view of SQL Server state information. We'll also take a look here at how to get help on DMVs because there's a lot of them out there. How do you find the one you're looking for and get help on the information that they return? From there, we'll take a look at data collection and how to set up data collectors, a great way that we can persist a lot of the state, activity information, and even performance information across SQL Server restarts. We'll also take a look at the canned reports that comes with data collection. Really nice, easy way to digest the information here using a lot of the reports built into SQL Server Management Studio. And finally, we'll take a look at how to identify bottlenecks using the Windows Performance Monitor. So if we're having performance issues, how do we know if it's a memory issue, a disk input-output issue, or a processor issue, or maybe if it's just a database design issue? Well, we can use the Windows Performance Monitor. There's some great counters that we'll take a look at both at the server level and the instance level to help us identify exactly where that bottleneck is. Let's head right over to the Virtual Nugget Lab and get familiar with the tools of the trade here as far as troubleshooting goes in SQL Server. So here we are in the Virtual Nugget Lab. I already have a Management Studio instance opened up and ready to go. But what we're going to do is open up SQL Server Profiler. So if you go to the Start menu, into All Programs, into SQL Server 2012, down to Performance Tools, you will see SQL Server Profiler. So it's its own separate interface here. And this is what you get when you launch it. It looks just like this. So the first thing you want to do is create what's called a trace. So if we click on the New button here, we can create a trace. Let's create this on our eval instance. And we can give it a name if we want to save the trace. For now, I'm not going to save it. I'll show you how to do that. But really, all we need to do is head over to our event selection and choose what we want to trace. So what we have here, we have events and we have columns. And these are some of the common ones here. This is kind of the default that gets set up for us. Audit login, audit logout. So anytime a user logs in, it's going to output into our graphical interface the information that we have selected in these columns. So the text data. Text data is useful for queries because we can actually see the query that was submitted, the application that it came from, the NT username, the SQL login name, and then we have, if it pertains, any sort of CPU or disk reads, writes, the duration, and you can see there's a lot of good information over here relating to what data will get outputted when that event occurs. Now, if you hit the Show All Events checkbox, look at everything we can trap for. We can trap for CLR related stuff. So if a developer wrote an assembly that we use in our stored procedures, anytime that assembly gets loaded, we can output it. Lots of database specific stuff from growing and shrinking. You can trap for that kind of stuff. Even for deprecation. You know, anytime you use a deprecated feature, if you want to see if an application uses a deprecated feature, we can hook Profiler up and trace this information out to a log file or a table in SQL Server somewhere, and then we can query that table later to see if people are using any deprecated features in their application. Other stuff here, locks, some good information to trap for locks, everything from deadlocks to chains to escalation and things of that nature. Performance, lots of performance stuff that revolve around queries and query plans. Scrolling down a little bit here, some of the big ones, lots of security stuff. If you want to audit anything security related, there's the sky's the limit there. Server level stuff. You can do things like server memory change, sessions there. Stored procedures and TSQL are going to be the real big ones for developers, or even for DBAs that are trying to track down a rogue query that's causing us problems. Another thing you can do, and I would advise doing, is using column filters. This is especially useful if you're trying to track or trap anything from a specific application. You can just come in here and under the like, type in the name of the application. you can see profiler throws itself in not like, so we don't get a lot of noise here in the data. Uh, Also, if you're trying to trap from a specific user or a specific process ID, or you're trying to track for a specific value coming in from a query somewhere, then you can put filters ahead of it. And I would definitely do this. It'll save you some time when it comes time to sift through this data. I can tell you there's been many cases where I'm trying to track down an issue or a rogue query, and I'll start up Profiler, I'll go to lunch, I'll come back an hour later, and I'll have a few million records in a table somewhere, and now I got to sort through all that data to find what I'm looking for. Not only that, but I've just trapped 2 million rows in an hour. That probably wasn't very good for the SQL Server or anybody using it in that hour. So do that. Use filters as much as you can. You'll save yourself some headaches. And I'll show you how to do that. One of the reasons I built an application is so we can put a filter on that application and see exactly what's coming from it. So to keep things simple here and just to start, I'm just going to accept all the defaults and hit run. All right, so Profiler's running, and you can see we're not even doing anything in the SQL Server, and it's tracking information left and right because the report server is pinging things, SQL Agent will be pinging things. So it's doing a lot of stuff, and in some of the tools up here, you can clear the trace window if you want to do that. You can pause it, and by the way, you need to pause it if you want to go into properties here and add more events. You can't do that while it's running, but if you were to go in the properties, add another event in here, put a filter on, add different columns and such, whatever you're trapping, and then you hit run again, it'll restart it for you. So right now, all this information is just getting logged to the Profiler here, the trace window. If you wanted to log to a file, we need to be completely stopped here. We can go into properties, and now we could save the information to a file, or we could save it to a table. And if we save it to a table, it's really nice because you can then put your own queries on top of the data to find what you're looking for. But this is the kind of thing you'll need to do if you're chasing a ghost and you don't know when it's going to show up. So trap for a specific time range, and you can even put a stop time on it if you want to do so here. But you trap for a specific time range, and then it'll just load all that data into a table. So this is good for one-off stuff, what we're doing here, where we're just simply tracing it to the window. Good for development, executing queries and seeing how they're hitting SQL Server and stuff. But if you do want to log it to a table, just specify table, pick your database, uh, and then name your table here, and then it'll start pushing that information out to a table. So let's test this out. Let's turn our trace back on, and we'll head over, I should say, to Management Studio, and let's just run a query against our AdventureWorks database here. Let's select star from production.product. There it is. So there we go. We just ran a query. Let's flip back to Profiler and see if we can find it. I'm going to pause it so it stops running all over the place here. And let's see what happened in that time frame. So we know nothing was going on in AdventureWorks until we did something. So let's scroll up to the top here. We'll even find out where we logged in at. So that looks like this is where it started the batch, use AdventureWorks. So this was our login right here. Use AdventureWorks is where it switched our connection over to the AdventureWorks database. So this is where it all began. And that's where it audited our login. And now here's where it gets fun. Because we have so much data getting trapped here, finding our query that actually did the simple select statement could be quite the challenge here. Let's see if we can eyeball it. If not, this is what filtering is all about. Oh, there it is. Look at that. So here's where it started. Here's where it completed. Now we could easily have just went in and put a filter for production.product and it would have found these very easily. But we can see this is where it started. It started, and when it starts, you won't get any information about how long it took because it just started. But when it completed, that's when you'll be able to see the reads it took. It took 0.99 99 milliseconds there to run, and some good information there, start time, stop time, the SPID that it came from, the client process ID that it came from, which is the SQL Server Management Studio's process ID. So some great information here, and we can see exactly what time it hit the server, how long it took, and then all the resource information that it required. Oh, and by the way, you can also hit the find button here. This would have made it easy to search for too. You can just put this on text data and go to town. So it's almost like a filtering system built in to the actual window here. Another way to do it. You can also launch Management Studio from here and launch Performance Monitor here. So it's just a great tool overall to work with. Now another thing I'll do here is let me get into the file system. And let's go into our support files. Let's go right into troubleshooting here. I built a .NET app called nuggetdemos.aw app. So what I'm going to do is I'm just going to go into the bin directory, debug, and I included the source and everything. So if you have Visual Studio available to you. You can open this up and look at what I did. Very simple application. It just hooks right into that product table, only now this query is going to come from an application, a .NET app, rather than SQL Server Management Studio. So it already ran, but we didn't turn our trace on. So let's turn our tracing back on here. Go back to our application, hit refresh. There it goes. It's hitting the database, and there it is. So now we can see exactly what it did. It took a little longer, a little more CPU cycles, a little more on the reads, but you can see here, here's the nice thing, you can see that it came from a .NET SQL client data provider. It came from our .NET application. It's really nice that we get the query that came over from the application. So just a great tool. Like I said, it almost feels like cheating because we're spying on everything that comes into SQL Server. But that's probably why it's one of my favorite tools, because it's so powerful that you're not, we're not guessing what's hitting our server. We know exactly what is hitting our SQL Server when and the kind of resources it's consuming. Another tool I want to get you familiar with here, because it's a lot like this, it's what's going to replace SQL Server Profiler in the future, is the Extended Events Profiler. So if we just go back into Management Studio, this is built right in to Management Studio. Underneath the Management tab, we see Extended Events. Let's expand Extended Events, and we have something called Sessions. So sessions are the equivalent of traces over in SQL Server Profiler. They contain events, what event data we want to trap when the event fires, and then where do we put all of this data that we're trapping for. So that's really all a session is, and SQL Server comes with a couple of built-in ones here, one for always on that's disabled and one for the system that's enabled. And if you right-click on any of these, you can see you can start and stop the session, you can watch the live data, much like we do over in Profiler. You can create a new session, you can export this session as a template, script the session out, or we can go into the properties to manipulate everything about the session. So I'll go into the properties here once I show you how to create a session using the wizard, which is fairly easy to do. Let's just right-click on Sessions here, choose New Session Wizard, and that'll pop us open the wizard with the welcome screen. We'll choose Next here. The first real screen here is just what do we want to name the session. How about we call this AW Product Queries. All right, so we want to trap all the queries going against the product table in the AdventureWorks database. You can also choose if you want to start the event session when the server starts. This is a great way to ensure that we don't miss anything the entire lifetime of SQL. So a great way to persist this session here across instance restarts. All right, so we'll choose Next here. The next one is, do we want to use a template, a pre-existing template? Goes back to the whole we can save templates of our own and then use those as the basis for future sessions. But if you do use a template, you just drop it down, choose your template. There's some pre-built ones in here. We're going to create our own from scratch, so we'll choose Next. And here's where we choose the event. Look at all the events. There's a ton of them in here, and you can scale them down by category. If you drop this down, choose a category, or you can just start typing in here and do a search out of this list, and you can search for specific parts of an event too. So let's say that we wanted to trap when a SQL statement completes. So we'll just type in SQL here, and these should look familiar. We have our batch completed, we have our statement started, statement completed, statement recompiled, all the stuff we were working with over in Profiler. So let's say every time a batch is completed, we want to trap the query to see what happened or to see what queries actually submitted. And you can see every event has its own set of event fields, event data that I can trap for. So we're going to choose batch completed. We'll just hit over here, and that looks good. And you can trap as many events as you want to as well, by the way. So we'll choose Next there. And these are global fields. So this is data that we can trap that applies to everything here for every event. So let's just grab a couple of here. Let's grab the client app name. Let's grab the database name. How about we scroll down a little bit? We need the SQL text so we can see the actual query that was submitted to the server. And let's just grab the username as well. Then we can choose Next. And here's where we can put our filters on. So yeah, you can see this is starting to look a lot like Profiler, right? So if you want to put filters, drop it down. You have things related to the SQL OS. We have things related to SQL Server. If we wanted to put a filter on top of the SQL text, we could do so right here. Now, I'm not going to do this right here. I'll show you how we can go and modify the properties of an existing session to add a filter. So I'm just going to right-click on the filter I added here and choose Delete. Then we'll choose Next. The next screen is where do we want to put the data? So we can save this to a data file, which is what we're going to do here. And I'm just going to browse and put the file right into our support files, 11 troubleshooting. We'll call this AW prod queries. And then we don't even need to put the .xl. It'll do it for us. But XEL stands for Extended Events Log File. And it'll also append some extra uniqueness on the end of this file name, as you'll see. You can also specify the maximum file size. If it hits this file size, you can enable file rollover, and it'll start pushing them into a new file. So we don't need file rollover. We won't get above a gigabyte for this demo, but you can do so if you need to trap large amounts of data. You can also scale back your data, and so you only trap the most recent events if you want to keep your data sets small. So we'll uncheck that and choose next, and that's it. So here's a summary screen where you can script it out if you need to port this to other servers and whatnot, or save it for later. When we hit finish, it'll actually create it in a disabled state. And on the last screen here, we can choose, do we want to start the event session immediately, and do we want to watch the live data on the screen as it is captured? So let's do both of those and hit close. It'll enable it and pop us open a tab here watching the live data. So you can see the events are starting to flow in here. And this is at the instance level. We didn't put any sort of filtering on it. So right now, any query that hits our entire instance is going to come into this session. And if we click around here, you can see we do have agent running, we do have reporting services running, so that's pretty much all that's going into here right now. And in fact, if you scroll down, you can see the SQL text. So if we double click on this, there we go. that's all that was there. It was just testing the connection. Looks like SQL agent was testing the connection here since we have master and target server set up. But if we find a reporting service one, here we go, and scroll down, here's the SQL text. You can double click on it to give you the full results of what the query that hit the server was. So all of the information we told it to trap is getting trapped: username, SQL text, the database name, all that good information, client app name. Now let's run our own query here. Let's run a select star from production.product. There it is. And let's actually run one from our application over here too. So there it is. So we ran a few of our own queries. Now if we come down here, and we have to hunt for it, and one easy way to hunt for this, and here it is. Here's one for Management Studio. You can right click on here and do filter. And we can also put a filter on those same columns that we could define in the session itself. So let's say we want to find anything that is like, how about product here? And you can use wildcard characters. Hit apply, hit OK, and look at that. Looks like we've got two of them, actually three of them. Oh, you know why? Because we altered the event session itself, so that's why it came in here. But here we go. Here's the one from Management Studio, and you can see the client app name is SQL Server Management Studio Query. And here's the one from our .NET app. .NET SQL Client Data Provider is the client app name, and there is the query. If we double click on it, we can see the whole thing. Now, doing a filter this way is really you're just filtering the view. We're not filtering the actual data going into the file. So if you want to filter the actual data coming into the session, you can go to Properties. So here are all the properties for a session. You can see a lot of the same things we took care of in the wizard are going to be in here. But the Events tab is where you're going to spend most of your time, because this is where it's going to allow us to add and modify existing events that we chose. So you could add new events in here. We could remove existing events. If you hit the configure, it'll slide everything over so we're working with the events that we have set up for the session. And if you click on your event, we can modify the global fields that we were talking about. You can add your filters, and you can also add or subtract event fields as well. And you can see all of these are kind of the default fields that every event will get. Resource usage and information here, and then anything custom associated with that event. Also, data storage. Here is our data storage, and you can see if you need to alter this, you can do that here. And there's some other targets that you can choose to pipe the data out to from our extended events profiler. So if you want to see all the information that's getting logged to your file, pretty easy to use these files. We don't have to worry about loading it into a table and working with it, because we have filters we can put on top of it now, and we can just take the file, which is recognized and registered on the system here, and drop it right into Management Studio. And that'll open it right up. And now we can put filters on top of this if we want to search for specific data. So there's real no need to log it to a file now and run queries on top of it. We can just log it out to its own file, launch it in Management Studio, and search around for what we're looking for. So that's the extended event profiler here built into Management Studio. Let's move on and talk about DMVs, Dynamic Management Views. So we'll open up our DMV script. DMVs are great for looking at real-time SQL Server state information. So, and these DMVs are used everywhere in SQL Server. Activity Monitor is built on top of it. But the only downside with using DMVs is that the data is not persisted across SQL Server restarts. And so that's a downside if you're trying to research performance issues, because with performance issues, you'd like to see a long ways in the past to see when it started. because a lot of the times, when you see a performance issue, someone may reboot a SQL Server at night, and now you just lost all that information. So it's great for state information, real-time state information from SQL. Uh, to see persisted data, we'll get into data collection here and setting up a data collector, because that's how we can persist this information across restarts and get a good visual across a longer period of time. DMVs can still give us some great information though. So what I want to do is show you how you can get help on DMVs and then find out what DMV you're looking for, because there's a ton of them. And there's also DMFs, by the way, data management functions, which I have a couple down here that I'll show you. But let's take the first one for instance. This one, sys.dm underscore us underscore wait underscore stats. Let's execute this. Anytime a thread or a process in SQL executes and has to wait, there's a reason it has to wait. And that's what this wait type is. It's a reason it had to wait. So anytime something waits, SQL keeps track of it. It'll up the counter by 1, it'll track how long it was waiting for, and add it to this list. So what you can do then is query this DMV, order it by your task count, and find out what the bottlenecks in your SQL Server are based on the task count, based on how often that wait happens. But how do we get help? How do we know what this wait type is? Well, what you can do is highlight the DMV, hold Shift on your keyboard, hit F1. That'll fire up the help viewer and take us right to the DMV and give us some good information about what the DMV is, what the columns that the DMV returned are all about. And if we scroll down, here are all the wait types and what they are. And you can see there's a ton of them. There's 600 plus of them. But, again, if you just find out what the top 5 are by querying the DMV, sort it descending by the waiting task count, you can then go into Books Online here and take a look at exactly what the bottlenecks are in your system. Not only that, but let's say that we wanted to find out what DMVs are available to us in SQL Server, broken up by category. Well, this button will sync our actual page here with the contents, and it'll take us right to it in the tree. And let's just collapse where we're at here, scroll up a little bit, and let me just expand this too so we can see a little better. But look at this. Here are all the dynamic management views and functions broken out by category here in SQL Server. So you can look in this area if you want to find out database-related DMVs. If you want to find out SQL Server-related DMVs, you can look in here, which is some of the ones that we're using. Here's our wait type one down here at the bottom. Here it is, wait stats. There's also wait tasks. You can find out what tasks have been waiting. So a lot of good information in here. In fact, let me give you another good example here of using a DMF. If we switch back here and scroll down to the bottom, here's a DMF. This one will give us index operational stats, and here we have the index physical stats. So if we switch to our AdventureWorks database, we'll be able to see all of the index stats for all of the index in the AdventureWorks database, broken down by clustered index, non-clustered index. It'll tell us everything from fragmentation, and this is a good one, because now we can see what indexes are fragmented and then rebuild them. So that's exactly what this will tell us to do here is rebuild these specific indexes. So kind of nice. So there's a lot of good information you can get here out of DMVs. Now the really cool thing I want to show you here is the data collection and the data collector. This is how I do most of my troubleshooting. These are great for, again, on-the-fly stuff. But once you set up a data collector, you can really get all the same information only in a nice report. This data collector has 3 reports that it comes with. One of them for analyzing server activity, one of them for analyzing disk usage, and one of them for analyzing queries. And the real beauty of this is not only does the data get persisted across SQL restarts, but we can create one centralized data collection database and then point all of our SQL instances at that database. So we have a nice centralized point of data collection on top of it all. So to configure, it's pretty simple. Let's right-click on data collection and choose Configure Data Management Warehouse. The first time we run this wizard is when we create the Management Data Warehouse database. So let's choose Next. And let's just create this database. We're going to create a new database. And let's just call this, how about SQL Stats? There we go. Everything looks good. We'll leave all the defaults for now and just hit OK. That'll create us a database. And now when we run and configure the data collector on all of our instances, we'll point it at this database. So we can choose Next. Here is where we can choose what roles, what users we want to allow access to this. And reader roles will be able to run the reports I was speaking of. Writer roles will be able to upload data collection sets, which we'll take a look at here shortly. And an admin can do both. All right, so we're good. We're currently an admin, so we'll leave this the way it is and choose Next, and then Finish. So this will just finish up the wizard here. It'll actually create the everything that data collection needs in the database that we created. Do security, and it's done. So we have our database set up right here called SQL Stats. Now let's configure data collection on this instance. So we can right click and do the same thing. Configure data management warehouse. This time we're going to run the second half of the wizard, set up data collection and choose next. Here's where we can point to our instance, point to our database, specify a temp directory, and choose next. Here it's just going to do a quick connect and validate against it. Looks good. We'll hit finish. And now we have, it's going to enable data collection here as the last step. And there it is. So now that it's configured, we can run those 3 reports. If you right click on data collection, head into reports, management data warehouse, we have the server activity history report, which gives us great information on CPU utilization, memory and disk utilization. We get some information on weights, and look at that, right? Looks familiar, just like activity monitor, only now we can use it across restarts. Here is SQL activity as well here, user connections, logins, logouts. You get a nice friendly graph. But what's really cool about this one is, again, everything's a drill down. So we can click on SQL Server weights. It'll take us in, and now we can zoom in and zoom out using the timeline here on our weights. And if you scroll down to the bottom, here's our friendly categories. And if you expand these, you can get the unfriendly categories, the system names we were working with earlier, to get some really good details. So these are great reports, and I especially like the historical snapshots here that we can zoom in to a specific day or time, or zoom out and see the entire year. And by the way, the other reports, the disk report is for disk usage trend. You can even zoom in to see the file usage of the actual data files that your database is using. And then the other one is for queries, query statistics. So you can find out the most expensive queries, and you can even zoom in on those and see what plans they used. So use the data collection and set up your data collector. It's very easy to do. Just create the management data warehouse database that I showed you how to do, and then run the second half of the wizard on all of your other instances pointing to that database, and then you can get some nice reports across all of your instances. Now let's take a look at another way that we can not only monitor for performance issues, but try to identify performance issues. So when things start to go wrong in SQL, you experience performance issues, and you're sure it's not something that's wrong inside of a database, not a design issue, but it's an actual performance issue with something like the processor or memory or the disk subsystem. How can we go about identifying which one it is and what we can do to go about fixing it? Well, let's minimize Management Studio, head into the Start button and into Administrative Tools, and launch the good old Windows Performance Monitor. So once this fires up, let's just maximize it and head into the Performance Monitor and remove the counter that's in there. So I want to get you familiar with some counters that we can use to both get a feel for the system to see if we're short on memory, if we need more processors, if we need to add more or faster disks. And then we'll take a look at SQL Server specific counters that we can use to see if SQL needs anything. So we're going to start with memory, and it's always a good idea when troubleshooting hardware bottlenecks to look at memory first, because a lot of disk issues can be caused by not having enough memory, specifically paging. When the operating system needs to swap out data in memory to disk, that's a huge performance hit. So let's hit the plus sign and start with some general memory tips here. We'll scroll up to the M. Where are you, memory? There it is. And expand memory. And the first one, very simple one here, available bytes, available kilobytes, available megabytes. Let's say available bytes, for instance. This will give us the current amount of available bytes on the system based on everything that's consuming it. So what this means is if you ever see a low value for this, it means you need more memory, right? Not too bad. Another one is pages a sec. There it is. This one will tell us how much paging our system is doing. So this should be close to 0, but if it's not, we may want to look at adding more memory. And by the way, backup and restore operations will do a little bit of paging, so don't be alarmed. That's okay. So if you're going to use this counter, just make sure there's no backup or restores going on, because it may skew your values and make you think you need more memory when you really don't. But generally speaking, anything above 0 when backup and restores aren't running could mean we need more memory in the system. So those are some good counters just to ensure you have enough memory in the system. Now let's go to SQL Server specific memory here, and we're just going to collapse the memory we're in and head down to the MS SQL. So look for your instance name, and let's start with access methods. So there's a counter in here that we can use to see how much page splitting is going on. And if we have a lot of page splitting, then we may want to think about increasing the fill factor. That's one way of doing it on our indexes. And there's a instance level setting to control that for new indexes, or rebuild our indexes more often. So here it is, page splits a second. So if this value is consistently high, then think about your fill factor or rebuilding your indexes more often. A couple of more memory ones that we can use at the SQL Server level here is there's one in Buffer Manager. So let's hit up the Buffer Manager node here and expand that. And the buffer cache hit ratio. This one we actually want to have a high value. Anything over 90% is good. It means SQL Server is reading data from the cache rather than from disk more often. So if this is below 90%, you may want to think about adding more memory. And finally here, let's head into the Memory Manager node. Down a little bit in here. And we have two counters that can help us determine if SQL Server has enough memory. Target server memory and total server memory. So we'll add both of these in here. So target server memory is how much SQL Server wants, and total is how much SQL Server actually uses. So the general rule here is if target is greater than total, SQL needs more memory. Now let's take a look at some disk counters that we can use to ensure that our disk subsystem is performing optimally. So we want to head on down to physical disk as our counter set here. And there it is, physical disk. And the first one you want to look at here is the percentage of disk time. So this is how much time the disk is spent, as it says down here, servicing read or write requests. So if this value is consistently high, then you want to actually look at another value, which is the current disk queue length. And if this value is high, what it's telling us is that we need faster drives, or to spread our files across more drives, or to add drives to the RAID array if we have a RAID array. This is really just how many requests are waiting for disk access. All right, so we'll add that one in there. And now SQL Server specific disk I/O, we need to go back into the Buffer Manager up in our eval instance, which is right here. And down here we have a couple of them. We have page reads and page writes per second. So these two values will tell you a lot about how much disk I/O your SQL instance is doing. So if these values are high, there's a couple of things we can do. The first thing, and the cheapest solution, is to check our indexing strategy. Make sure you have a good indexing strategy in place, that you have indexes, and that your indexes have good coverage. You can also check the database design, and if you're in an OLTP environment, make sure that it's normalized. On the more expensive side of the solutions, memory and disks. Make sure you have enough memory, and make sure that your disks are fast enough, or add more disks, and again, spread those files across disk. So let's add these in there. And the last area I want to show you here is processor, CPU. How can we look at CPU performance to ensure that we have enough CPUs, or if we need to add CPUs or upgrade our existing CPUs? So let's head on down here to the processor node. There it is. Expand this. And some of the big ones here that we can really see if our processor is struggling is we could use privilege time, which is how much time the processor used fulfilling those I/O requests. And then we also have user time, which is telling us how much time the processor spends. If we have a dedicated SQL box here, how much time it spent fulfilling those SQL Server requests. And there's actually one more that we can use for processors, and it's down in the system area. So let's find system. And if you scroll down in here, it's going to be processor queue length. This is how much time the threads are waiting to be executed. So let's add this in here. So these bottom three then will give you a good indication if you need to upgrade existing processors or add more. So from here we can hit OK. And now we'll get a graph with all of the counters where we can monitor their values. And this is great for, again, real-time processing. So if you want to persist this information, you can also set up data collector sets here in the performance monitor. So you can run through the wizard, set up a data collector set, and then you can set up data collectors within that set. So I name my sets SQL Server, for instance, and then I'll name the data collectors for each area. So I'll put all the memory counters inside of a memory collector set. Same with disk, and then same with processor. So in the CBT Nugget, we got familiar with troubleshooting SQL Server and all of the tools that we can use in SQL Server and Windows to help us identify performance issues. So we started off there with the SQL Profiler, a great tool that we can use to spy on SQL Server and, again, view all the real-time events that are happening. We then got familiar with Extended Events Profiler, which is included in SQL Server Management Studio, and we can use to do a lot of the same things we do with SQL Server Profiler. From there, we got familiar with DMVs, dynamic management views, that we can use to examine, again, the current state of SQL Server, real-time information. And then we saw we can persist that data using data collection and how to enable and configure data collection and some of the reports we can use to view all that information across the lifetime of a SQL Server or even across an extended time range that goes beyond restarts of the SQL Server engine. At the end of this nugget, we got familiar with the Windows Performance Monitor and some of the good counters we can use to track down performance issues and bottlenecks in our system. I hope this has been informative for you, and I thank you for viewing.